Hello, we are Group 4 presenting our Project 2 and 3 for Data350. The topic we chose for this part of the project was examining the influence of demographic and social determinants on substance use using the NHANES raw dataset. In this presentation, we will explain how we approached performing the exploratory data analysis, the graphs and visualizations we made, and the conclusions we came to. For some background, the NHANES raw dataset contains data collected by the U.S. National Center for Health Statistics, or the NCHS, and the dataset includes 75 variables, most of which are responses to questions related to the respondent's health, demographics, and lifestyle. We chose the topic of substance use because the NHANES raw dataset covers a wide range of questions related to that topic, including the use of alcohol, cigarettes, marijuana, and hard drugs by participants. Additionally, it has been proven that substance use is influenced by both demographic and environmental factors, with the American Addiction Center stating that only about 50% of a person's risk of addiction is impacted by their gene expression. This shows that there's a lot to explore in regards to what can influence a person's propensity to drink, smoke, etc. Additionally, according to the Substance Abuse and Mental Health Services Administration, in 2023, about 59%, or 160 million Americans above the age of 12 have used substances, whether it be alcohol, tobacco, or illicit drugs, in the past month, so the topic of substance use is very relevant to the lives of Americans today. And below you can see are some examples of how substance use varies across demographics.
The first thing the Data Summary tab does is provide a glimpse of the NHANES raw dataset used in the Shiny app. This way, the user knows exactly what variables are used and what values they commonly take. Next, the user can select any of the variables shown in the glimpse. For example, suppose they selected the race 3 variable. Once they select the Visualize Action button, the Shiny app will display the summary statistics and plot. Since race 3 is a categorical variable, the Shiny app will display the count of each category in race 3 and display a bar chart of these counts. The Shiny app allows the user to select any combination of the variables shown in the glimpse. The Shiny app will display the summary statistics and the plots of all the variables they select. For example, suppose the user selected race 3 and BMI variables. The Shiny app will display the counts for categorical variables and the 5-number summary for numerical variables. Similarly, the Shiny app will plot a bar chart for categorical variables and a density chart for numerical variables, all side by side. The Hard Drug tab seeks to answer the guiding question, what participants have used hard drugs and how does participation vary by race, gender, and age? This tab allows the user to choose categories of race, age group, and gender, and then display a pie chart showing the proportion of participants that have used hard drugs in blue. For example, suppose the user selected participants who are white, between the ages of 50 and 59, and are female. The app will display this pie chart showing that 29.2% of participants who match these characteristics have used hard drugs. Building on that example, the Shiny app allows the user to select any combination of races and age groups available in the NHANES raw dataset and will display pie charts for all combinations side by side. Here, the previous example is expanded to show pie charts for all combinations of race and age groups for participants who are female. Then, the user can select to include all combinations of gender. This will result in pie charts showing the proportion of participants who have used hard drugs for all combinations of gender, race, and age group, as shown here. Of course, the previous examples have pie chart plots for if the user selected only male participants. The Cigarettes tab seeks to answer the guiding question, what age do participants first start smoking cigarettes across poverty level, marital status, and race? This tab allows the user to select married or not married and different values for race, and then plots the age the participants first started smoking cigarettes versus poverty level, where smaller values indicate more poverty. Here, for example, suppose the user selected married and chose black for race. The Shiny app will first display contour lines and a scatter plot to show the distribution of initial smoking age versus poverty for this group of participants. Then the Shiny app will render a scatter plot with a smoothing model below. The Shiny app allows the user to select any combination of married or not married in any of the race categories. The Shiny app will update the contour lines and scatter plot to include data from all selected groups. Then, the Shiny app will produce smoothing models and scatter plots for each combination of the chosen variables.
For the marijuana tab, we sought to explore the question, how does marijuana use relate to alcohol consumption, BMI, and cholesterol across race and gender? Data comes from the NHANES-RAW 2011-2012 year and is filtered to aged 18 and older adults. So alcohol use is defined as consuming at least 12 drinks in any 1 year, and it is coded as yes or no. This current plot is showing BMI by marijuana use and alcohol use across race and males. As you can see, most of the data is coming from Black and white participants, and there's less data for the other racial categories. Generally, across all racial groups, we have a BMI between 20 and 30. For Mexican, white, and Asian, the BMI is relatively consistent across marijuana and alcohol use categories. For Black participants, slightly higher BMI when alcohol is used here, and then there is a slightly lower BMI when both marijuana and alcohol are used. There was a higher BMI observed in participants who did not use marijuana or alcohol in the other category, BMI by marijuana use and alcohol use across race and females. For the first plot, Asians, we can see that their BMI is slightly higher for participants who use both alcohol and marijuana, and their BMI is averaging about 20. For Black females, the median BMI is higher for participants who do not use marijuana or alcohol, as you can see here, and the average BMI in this category is about 30. For Hispanic females, there is a higher BMI observed for participants with no alcohol and no regular marijuana use, and there is a much larger spread. For Mexican females, the BMI is similar across no marijuana and alcohol categories. However, for regular marijuana use but no alcohol use, the BMI is noticeably lower. For white females, the BMI is higher for participants with no marijuana and no alcohol use, and the other categories average around 25 BMI. And then for the other racial category, there is a very high BMI, around 40, for those that regularly use marijuana and don't have any alcohol use, or reported no for alcohol use, suggesting there are other factors that are influencing BMI in this group. This tab is showing the total cholesterol by marijuana use and alcohol use across race and males. The first noticeable thing is that there is a box plot missing for other and Hispanic males for when alcohol use is reported as no, suggesting a small sample size. For Asian, Black, and Mexican males, the cholesterol is about the same for those that report regular marijuana use and either alcohol use categories. There is also a higher cholesterol for those that report no regular marijuana use but high or yes to alcohol use for Mexican, male, and white and Hispanic racial groups. And then for Asian males, there is a lower BMI for those that report no regular marijuana use but yes to alcohol consumption. For the last plot, it is showing the total cholesterol by marijuana use and alcohol use across race and females. For Asian females, Black females, Hispanic females, and Mexican females, the general trend is showing a higher cholesterol for those that report alcohol consumption regardless of marijuana use. There's a noticeable difference in white females and other females. For white females, there is a lower cholesterol for those that report no marijuana use and no alcohol use. And then there is a slightly higher cholesterol for those that report regular marijuana use but no alcohol consumption. And then for the female other category, there is a lower cholesterol for those that report alcohol consumption regardless of marijuana use.
So these are some of the summary statistics for the main variables used in the alcohol tab. This tab explores the question, how does reported alcohol consumption vary by marriage status, race, and gender? And as you can see, married is the dominant group. I also want to note that most racial groups have a similar number of respondents except for other, which has significantly fewer, and also that self-reported alcohol consumption is heavily left skewed, which is why a log transformation is applied to the KDE plots. These are the faceted KDE plots with all races and genders selected. The plots are faceted by race and gender, while the fill of the distribution represents marriage status, and the X values represent the log transformed estimated number of days spent drinking in the past year. As you can see, men tend to cluster around certain values while the women remain more evenly distributed, with some exceptions, of course. This is what happens when you select only one gender. This is an example of setting up the graphs to compare never married and married white and black participants. As you can see, the male groups have similar distributions for both races and marriage statuses, while the female black group is more bimodal compared to the white female group.
We visualized substance use patterns across demographic and health factors, answering our 4 key questions. First, regarding hard drug use, overall, males reported higher levels of use, but patterns vary by race and age, highlighting demographic differences in participation. Secondly, for the age participants first smoked cigarettes, usage is mostly concentrated at the lowest and highest poverty levels, with little difference by marital status or race. Third, examining marijuana use in relation to health outcomes, we find it is not strongly associated with BMI or cholesterol, while alcohol use shows a clear association with higher cholesterol across race and gender. Finally, looking at alcohol consumption patterns, males tend to cluster at the higher end of self-reported drinking, regardless of marital status, whereas females are more evenly distributed across drinking levels. Overall, these results indicate that substance use behaviors are influenced by a combination of gender, race, and social determinants, such as poverty, marital status, and access to resources, with alcohol showing the clearest link to health outcomes.
A little demo of the app that we made. So here we have a summary tab where you can see summary statistics for all of our variables, as well as the type of variables that we're using. So let's try alcohol per year, number of days participants reported drinking alcohol per year. See, now you can see the distribution as well as the summary statistics for this variable. Now let's try it with both gender and this. And see, now you can see the gender distribution of this data set. Let's go over to the hard drugs tab. So this is the question we're trying to answer, and I can just show you how this one works. I can just change a few things and see what happens. There we go. This will only show male. Now let's go to this tab. And this is the graph. Isn't that neat? Okay, and here you can actually change the y-axis. And that's what happens. And here you can also change the different distributions. So yeah, this is a small demo of our app and what we were able to think of given this data set. So yeah, I hope you enjoyed this.